doing that for you. All right, let's see. All right, so Maurice, will you let me know? Okay, awesome. I will get that graded in just a little bit. Maurice, will you go to the Unit 2 writing assignment? And let's see. Kiara, will you go to the Unit 2 writing assignment? Let's see. Actually, let's do it this way. Okay, awesome. We're going to get started here in just 1 second. Oh, sorry, Kira. You can be there too. I actually meant the other Kira. You might have finished yours. Let's see. Okay, so actually both of you can stay there because we need to both make a few adjustments. Let's see. Valeria, you can stay there as well. Anaya. Okay, perfect. That's what we're going to work on. Okay, Anaya, perfect. You can stay there. Mason, will you go to the Unit 2 writing assignment? Isaiah, will you go to the Unit 2 writing assignment? And RJ, you're good. If you want to go to a different assignment, I can help you figure out where you need to go. All right, guys. So hopefully you're all on the Unit 2 writing assignment. So let's start on slide 2. This is number 1. So can somebody tell me in the room chat, how do we know if something is or is not a function? RJ, why don't you work on the Unit 3 writing assignment, okay? All right, guys, so how do we know for the Unit 2 writing assignment? Yeah, good, Kiara. So Kiara said, if the x values do not repeat, then it is a function, okay? So I want you to look at your writing assignment, slide number 2, problem number 1. And you're going to write your answer. Either, yes, it is a function because x values don't repeat, or no, this is not a function because we have repeating x values. Okay, so go ahead and write your answer. And then we're going to go over to slide 3. I'm going to put a problem up here on the board. Aubrey, let's see. Let me look at your grade book real quick. Right now, what I'm doing is I'm going over the Unit 2 writing assignment. So it looks like we can make some changes on yours. So will you go to the Unit 2 writing assignment in Class Kick? Okay, so now let's everyone go to slide number 3. This is problem number 2. My formula and my function on the board are different numbers than yours. So you're not going to write down the exact numbers I have, but I want you to pause for a second and look at the new row screen. Okay, I'm going to show you how to do this, and then you are going to go do it on your own. All right, so this says that given that the function f of x equals, mine says 3 times 2 minus x plus 1. What does the notation f of 4 mean? Okay, so from this top one, f of x, to the bottom one, f of negative 4, the only thing that has changed is instead of an x, I have a negative 4. Okay, so f of negative 4 means that I am plugging in negative 4 for every x. Okay, now I want you to look at your problem on your screen in Class Kick, and I want you to answer part A. What does f of negative 3 mean? Okay, Erica, I will get to grading after the after small group, okay? Okay. So, let's go ahead and do part B together. So, if you'll come back to new row, it says to go ahead and evaluate f of, mine says f of negative 4. So anywhere that there was an x, I'm going to plug in negative 4. Everything else is going to stay the same. So I have my 3, parentheses, 2. This is the minus sign. Then I have minus 4. This is the end of my parentheses. Maybe. Why is this not working? Plus 1. All right, so this inside the parentheses, 2 minus negative 4. The double negative becomes positive, so plus. So if I was going to rewrite this, this would be 3 times 2 plus 4 is 6, plus 1. 3 times 6 is 18. 18 plus 1 is 19. So f of negative 4, when x is negative 4, the y value is 19. All right, now I want you to go to Class Kick and do your part B. I'm going to leave my slide up there just for a minute so that if you need some help, you can come back. it's graded, Kiara, because we don't have school tomorrow. So it's technically due today. So we don't have school tomorrow or Monday, but I didn't want to wait until tonight to put in the zeros. So if I put in zeros already, then y'all get notified that you have a zero in there. So then that reminds you to go in and do it. So I didn't want to wait until after the weekend when we don't have school and people go into the weekend thinking that they have a higher grade than they do. All right, so now let's go to slide number 4. This is problem number 3. So I'm going to draw a linear function that is very similar to the one that's on your page. It's different, but it's similar. So let's look at part A. Part A says, write an inequality to represent the domain of the part shown. Okay, so when it says inequality, that means I'm going to take my x. Let me make this bigger. X. Okay, and I'm going to put my less than signs on either side of it. Okay, I'm writing an inequality. So I'm going to go ahead and get myself set up. Okay, for domain, this is our x values, domain. So I'm going to come at my graph from the smallest value. The smallest x values are on this axis over here. So I'm going to come from the left, and at this point of this x value, 2, that is where I hit my graph, the first part of my graph. So I am going to write that number 2 over here on the left side. That is the smallest value. I'm going to leave this as a less than sign because this is an open circle. So it does not include the number 2. Okay, now I have to find my largest value. So I'm going to come from the right. When I get to this point of my graph, it is an arrow, which means it is going to continue on. If I were to continue on the x-axis, that is going to go to positive infinity. That's your answer. That's not your answer. That's the answer for mine. So you look at your graph and do part A. Find the domain for your graph. RJ, I will have to look in just a little bit, okay? Let me finish this tutorial on Unit 2, okay? Hey, Gabby, are you able to get logged into ClassKick? All right, let's come back and we're going to talk about our range. So part B says write an inequality to represent the range of the part shown. Okay, so I know it's going to be an inequality, and I know range is talking about y value. So I'm going to go ahead and get myself set up. Okay, range is y values. That's the y-axis that goes up and down. So first I'm going to determine my lowest value. So I'm going to start down here in the negative numbers. Okay, so the first place I hit is going to be, again, this open circle, which is at the y value of 1. On your assignment, on your class kick, you are going to hit that arrow first. Okay, so your left bound, your first number in your range is going to be negative infinity because you hit that arrow. Now I'm going to come from the top. The highest point, again, is this arrow. So the arrow means I'm going to infinity. Yes, this is an example for question number 3 on slide 4. So now you should be able to do A and B. Alrighty. So this next one that we're going to do is going to be like slide 5. All right, I'm going to go ahead and type out an example problem. So we're going to say John has a summer job that pays him $9 an hour, and he works between 10 and 38 hours per week. Alrighty. So his weekly salary can be determined by the equation S equals 9 times H. S is salary, and H is the number of hours. Okay, so this is my equation or my scenario for my example in the new row, okay? Okay, for those of you that are just getting here, we're working on Unit 2 writing assignment. So if you'll log into Class Kick and get to your Unit 2 writing assignment, we're on slide 5. All right, so for yours, number 1 says, what is the independent variable? Okay, the independent variable is the variable that changes. So if I'm looking and talking about this problem, John's salary doesn't change on its own. What has to change for his salary to change? What changes every week? Here it says he works between 10 to 38 hours per week. So his independent variable here is going to be the hours, good, Kira, that he works. That's what changes. The independent variable is the hours. So go ahead and fill out your number 1. Number 2 says describe the domain and range for this problem using appropriate notation. Okay, So domain is the same thing as our independent variable. So our domain is the hours. We want to list or write out the possible hours he could work. This one, you have to ask yourself, okay, could he work 10 and a half hours? Yes, people work half hours all the time. Okay, so this is going to be an inequality. So I'm going to go ahead and get myself set up for an inequality. I put X in the middle because I'm talking about domain. So what's the lowest value? 10. The highest value? 38. Go ahead and plug in your domain on your page. So now, to find the range, you're going to plug in the domain to your function. So my function was S equals 9 times H. So I'm going to take my lowest value. So I'm going to do S equals 9 times 10. And then I'm going to do S equals 9 times 38. So wherever your variable was, you're going to plug in the two parts of your domain. So that means that my range is going to be from $90 to $342. You're going to have different numbers because you have a different function and a different hourly wage and a different domain. So go ahead and do your part to the domain and the range. Okay, so let's go ahead and talk about part 3. For part 3, I'm going to say that I have the ordered pair 20 and 180. Okay, because when I plug in 20 to this function, 20 times 9 is 180. So what does this mean when it says, what does this represent in the context of this problem? So this means that John worked 20 hours because that's my X value. So since he worked $20 or 20 hours, he earned $180. So you're going to make yours fit for what your problem is and your numbers. Okay. When you're finished with slide number 5, go ahead and go to slide number 6. For this one, I'm just going to give you some tips, and you're going to do this while I'm talking. All right, so for part A, I'm going to give you a hint. For part A, when we read our problem, it says you're in charge of reserving hotel rooms for a youth baseball team. Each room costs $89 per night, and you need the room for 2 nights. Okay, so 89 times 2 is going to give you $178, okay, per room for the weekend. Okay, so your function is going to be $178 times X, where X is the different number of rooms you're renting. All right, it says you're going to need at least 10 rooms. So you're going to need 10 for sure, but no more than 16. So we have 2 ways to represent domain and range. We can write them out as an inequality, like we were on the last slide, which means all numbers in between, or we can write them out as a list. So what you need to do is ask yourself, okay, what's the domain? So what is changing? The number of rooms. So can I have 10.5 hotel rooms? No. So you are going to write your domain as a list. You are going to list it out. So I could have 10, 11, on and on. You write out all the numbers. Your range then is also going to be a list. You're going to plug in all of these numbers that you wrote out, plug them in. So 178 times 10 would be $1,780. You're going to go through and plug them all in. So I'm going to pause and let you do that. It's going to take a few minutes. That's okay. We're going to get to 6B. I'm just going to give everyone just a second to get through 6A. What do you have, Kiera? What do you have for your function on 6B? Oh, 6A range. Okay, what is your question? Did you list out your domain? Okay, did you list out your domain? I can go to your assignment. Let's see. So to find range, you plug in your domain to your function. So see where these red lines are right here? This is how I'm finding range. I take my domain, the first number of my domain, 10, and I plug it into 178x. So 10 goes in for x. So this is 178 times 10. I'm going to repeat that for every single number I wrote out in my range. Okay, let's see. So, Kiera, you need to... Okay, so write down what I'm writing down on the screen. Okay, your function should be this. F of x equals 178 times x. You just wrote 89. Okay, that's not the domain and it's not the function because it's $89 for 2 nights, right? Everyone's staying for 2 nights. So we have to say, okay, you're right. That's the cost per night for 1 room, but they're staying for 2 nights. So we're going to go ahead and multiply that by 2. That's how I got the 178. Yeah, but go ahead and get rid of that D and R or move them down a little bit so you don't get confused. So instead of putting a dollar sign, Kiara, write it exactly like I've written it on the board here. I highlighted it in blue. Write f of x equals 178 times x. Okay, this is going to satisfy this part right here where it says write a function. Okay, so function has to have a variable in it. Yes, I can. Yes, that is perfect. Yep. And then you have your function correct. Very good. So go ahead and try your domain. This one will be an inequality for part B because our range, our domain, our weight is our independent variable. That's what's going to change. And it could weigh 25.5 pounds or 27.2 pounds. Okay, so that one, this domain and range, you're going to write as an inequality. All right, Kiara, so now go ahead and we need to write out our domain. So we're going to list out all the possible numbers of rooms we're going to need. So just like I did here in green, this is your domain. So you can put D. You don't have to write the word list. Okay, but you're going to put D and then you're going to use these squiggle brackets and list out all the possible room options. Yes. Okay, London, I will help if we have some time at the end. Let me get through 6 and 7 first, and then I can go back to questions 2 and 3. Okay, Anaya, let me check yours. We are going over the Unit 2 writing assignment. Okay, Anaya, yes, perfect. That's the domain. Yep, and that's the range. Perfect. Okay, so now for your part B, Anaya, you are going to, for your domain is going to be what changes. So the thing that's going to change is the weight. So these are going to be your two bounds for your domain. So you can get rid of that 36 and the 25 on the bottom and go ahead and rewrite those. I'm going to go over that in just a second here. Okay, good, Kiara. So now that was your domain. Now you're going to find your range. So you're going to do 178 times 10, 178 times 11. So you'll do it times 10, write it right here. Then times 11, write it next to it. Okay, that's how you find your range. So go ahead and work on that. I'm going to give you like a minute or so, and then we're going to go on to part B. Slide 6, and we're going to be on part B. So we have this youth soccer team, and they're flying to a tournament. The airline needs an estimate of the total weight of the team's luggage. You determine there will be exactly 36 pieces of luggage, and each piece will weigh at least 25 pounds and no more than 45. So first it says write a function for the situation. Okay, we know we're going to have 36 pieces. X is going to be the weight. Each of the weights could be a little different. Okay, so weight is going to be our domain. This one is going to be written as an inequality because a piece of luggage can weigh 28.5 pounds or 32.1 pounds. Okay. So for my domain, what you're going to do is reread your problem. You're going to tell me what's the lowest value. That's going to go in the blue box. What's the lowest weight it could be? And then what's the highest weight it can be? Just like we did for the last couple problems when we're finding the range. We find range by plugging the domain into the function. So whatever your lowest value was, plug it in for X. So 36 times your lowest value, that's your lowest range value. 36 times your highest value, that's your highest range value. Good job. All right, so let's go ahead and talk about now slide 7. Okay, so slide 7 is asking you which of those is discrete and which is continuous. So think about those words, discrete versus continuous. Continuous means it continues on. Okay, so it's a range. Continuous is going to mean you're writing it as an inequality. Continuous includes decimals, it includes fractions. That is a continuous function. So between scenario A and scenario B, which of those is a continuous function? A discrete function is when you have a certain list of numbers. Okay? So it only contains a set number of points. Discrete is a list. So now you can go in on slide 7 and tell me which one is discrete and which one is continuous. Okay? All right. London, I'm going to head back up to, this is slide number 3, question number 2. Okay, so I'll go to your page if you want to go to question number 2. We can meet there and I'll go over this real quick. I also recorded it, so you can, if you want to go back and like rework it at the same time, you can. Okay, so this tells us this is the function given that f of x equals 2 times 4 minus x plus 3. If you look at my Neuro board, I gave a different function because I didn't want to do the actual problem for you. Okay, and so the next part says, what does the notation f of negative 3 means? Well, I'm going to, on my board on new row, I'm going to change that number so that I'm not doing your work for you. But the only difference between this green one up here, f of x, and f of negative 4 right below it is that instead of an x in parentheses, we have a negative 4. So if I say that f of negative 4, that means I'm plugging in negative 4 for every x. So now you look at part A, what does f of negative 3 mean? So you can go ahead and write that down. All right, guys, if you don't have any other questions, you are free to go. Have a good weekend. So, London, f of negative 3 doesn't equal x. Okay, do you see what I wrote over here on mine? I said that f of negative 4 means I'm plugging in negative 4 for every x value. So that's what you need to write over here. But you're not going to be plugging in negative 4. You're going to plug in your own negative 3. No, next week we're going to go over the unit 4 that we're starting on Tuesday. Okay, so then, London, what we're going to do is do exactly that. So to evaluate what is the value, you're going to do exactly that. So you're going to rewrite this equation up here. You're going to write it underneath, but instead of putting the x, you're going to put in a negative 3. So go ahead and write that, and then I can help you from there. This is for part B, where I highlighted the value of f of negative 3. We're going to go ahead and evaluate that function. So we're going to find out, what does f of negative 3 equal? It's going to equal a number, because negative 3 is our x value. So we're saying when x is negative 3, what is the y value? Okay, so hold on one second. You need to write it. So keep your parentheses in there. So 2 times 4 minus, so you have the 1 minus sign. That's from the formula, but then you didn't include your second minus sign. So it should be f of negative 3 equals 2 times 4. This is the minus sign from the formula. This is the negative 3 I'm plugging in. So when I have, oops, that's not a negative 4. When I have 4 minus negative 3, that double negative becomes a positive. Okay, so now you're going to get 2 times 4 plus 3. So go ahead and finish that one out. You can type that in your calculator if you need to. Yes, I can. Yeah, perfect. Good job. Yeah, you're welcome. Have a good day. All right, London, are you confused? Oh, there you go. Okay, I see you right now. Thank you. So we're not messing with anything on the left side. F of -3 is going to stay. Okay, F of -3 is just a fancy way to say y equals. Nope, we're not adding or subtracting anything. So all of these numbers on the right, those are all like terms. So now you're just going to do order of operations, okay, which is PEMDAS. Okay, so do parentheses first. You don't have any exponents. Then go ahead and multiply, and then you're going to end up adding. So you're going to do parentheses first, then multiply that by 2, and then add 3. For the range on 6B, yes. So for the range on 6B, I can go back here, Kira. You are going to, whatever your domain was, you'll have a number in this first blue box, a number in the second one. You're going to plug those numbers into your function. So plug them in, and that will give you your two values for the range. I'm going to go ahead and stop the recording.